All right, everyone. Welcome to our first meeting of the semester. This is an introduction to Linux. And I don't know, pretty straightforward topic. For this meeting, I'm just going to give a presentation and then we can break off into, I don't know, we can do like Try Hack Me or Over the Wire Bandit, whichever one you guys want. So, today I'm going to talk about Linux as when I refer to Linux, I pretty much just refer to it as the operating system. I don't care about the whole GNU plus Linux terminology. But if you're not familiar with what an operating system is, it just lets you use a computer. So for example, there's the Windows operating system, there's the Mac operating system, and then there's the GNU Linux operating system. And the one we're mainly particularly interested in is the one on the right here. And an operating system on, I guess, a more technical level is these three parts over here. So on the very bottom you have the hardware. Everyone knows what hardware is. It's your CPU, the RAM, your hard drive, I don't know, your motherboard, the fancy tower, stuff you can physically touch. But the operating system is the software that runs on it. And at the very bottom is the kernel. So the kernel, or in our case specifically the Linux kernel, controls access to the hardware. It runs the processes and it sections off different parts in the RAM. It's very low level and lots of C programming. I believe Windows uses something else called the NT kernel, and then Mac OS uses, I don't know, I think it's called the XNU kernel. It's based off of BSD, but I don't remember what it's called. But you can't really do much with the kernel. It just, tells hardware what to do. If you want to actually use it like a normal human being, you need a shell. And the shell is pretty much basically a command line interface that lets users, so me, you, people with fingers, use the kernel. An example would be bash. So if I open up a terminal, and hopefully you guys can see this is a shell where I can run commands like, I don't know, ls, who am I, stuff like that. That's a shell. Setting on top of the shell are applications. So that's something like a desktop environment. Web browsers, different CLI apps like tar or zip, etc. And all of these are what make up an operating system. So Linux is an example of this, and it's used pretty much everywhere. Anything you can think of that runs a computer is, can probably run Linux. It's used on, desktop machines. It runs on smartphones, like Androids, for example. It runs on servers in the cloud. It runs on IoT and embedded devices like routers and smart coffee makers and fridges. It runs on the International Space Station. Anything runs Linux. If it exists, it runs Linux. It's Rule 34. There's a lot of different varieties or flavors of Linux, or rather the GNU Linux system. They're called distributions, and a distribution is an entire operating system. Since Linux is very customizable, no one can agree on literally anything, so they have their own distributions or flavors of the operating system, and you can pretty much pick whatever you want. And then there are repositories. So different Linux distros will have its own set of repositories, and it's essentially a location for a set of packages. And a package is just, a set of files for an application. So if I want to download a program like zip, I would need to download files from the repositories And those files include, I don't know, maybe zip, unzip, and other documents and man pages for the zip command. If you want another analogy, it's like the Windows Store, but like what if it was actually good and worked? Here are examples of some distros you might have heard of. There's a lot of them. There's definitely a lot more than 6. For example, there's beginner-friendly and daily driver distros like Pop! OS and Endeavor. There are pen testing distributions like Parrot OS and Kali Linux, which aren't actually meant to be installed on bare metal or used as daily drivers, but there's a different distro for different purposes. Does anybody have any questions on, I guess, what Linux is? Does anybody still have no idea before we start moving on to, I guess, like shell commands and the file system? Any questions? All right, I guess I'll move on. These are some really common shell commands. I only listed a few of them because there's way more than I can think of off the top of my head. The ones that are listed here are stuff like ls, which is to view the contents of a directory. So let me show some examples. Here I have a command line interface. I can run some shell commands like ls, which views all of the files in my current directory. I can use rm to delete files. So like if I delete, I don't know, a file called sussy, but it's a directory, so I have to use rmdir. I can create a directory, such as make dir foobar, and I can use cd to change into the directory. So it's like in Windows, if you open up a file browser, you double click a folder, you enter the directory you can see inside of it. It's essentially the same thing. There's also a command called cat, which prints the contents of a file. So if I make a file, I can cat the contents of it, and it just prints it out to the screen. Oh, that's not cat. And it just prints the contents to the screen. Very simple stuff. You can also use stuff like the find command to just find files. You can do some weird queries like find any files on the computer owned by the user sadly, stuff like that. There are also shell commands to, those are all commands just to interact with files. But there's other commands too, like I can run ps to list running processes. So for instance, I just ran the ps command. I'm running my shell called zsh, and you guys can't see it, but I'm running like a git process. So if I do something like git init, this is what this process is. There's the man command, which is short for manual. So if I want to read a man page, I can do something like man ls, and I can read the entire manual for the ls command. There's a lot of it. There's, I don't know, another command is Systemctl, which stands for system control. I can control services, so I can check the status of my DHCP daemon. Oh, it's active and running. I can control DHCP, I can start it, I can stop it, but I don't want to stop it now or else I'll get disconnected from the internet. There's wget and curl, which downloads files from the internet, so I can do something like curl https google.com, and I get a response back saying, oh, it's moved to www.google.com, and I just made a GET request to google.com with a curl command. There's a command like Netstat, which reports all network connections on my machine. There's a whole chunk of them because I'm running a web browser and Discord and all that stuff. And then there's SSH, which lets me remotely log into a SSH server. So if I have a server called, I don't know, 192.168.0.5, this would be the sort of thing this would be what an SSH command looks like. Anyway, there's a whole bunch, and hopefully you guys will have some practice using some shell commands in like a try hack me room or over the wire. The file system structure is actually pretty well organized on a Unix-like system, and it's pretty much the same for every distro. There might be some variations, but every distro is usually organized the same way. You're probably very familiar with the /home directory. So when you open up a shell or when you log in, you'll be dropped in your home directory. So whenever I open a terminal, I'm dropped in /home/ whatever my username is. And that's where all of my files are, the home directory. There's the /bin directory, which contains essential commands and essential binaries. So if I do /bin/bash, that's the bash is contained in the /bin directory. A lot of these are maybe symlinked to /user/bin, which is actually most commands. So if I use something like which bash, it's actually located in user bin bash. So I wonder if I do file/bin bash, it might be a symlink. File bin bash, file user bin bash. Okay, well, it looks like I just have 2 copies of bash. But essentially, as you can probably tell, the entire file system is kind of like an upside down tree where the root is at the top and then it just branches down into leaves. File permissions are kind of quirky. Let me see if I can pull up a good example. Anyway, let me touch. So anyway, in this example here, I have an ls-tac-la, which lists all files from top to bottom in order, and it lists all files, including hidden files. So examples of hidden files are dot and dot dot. And the dot and dot dot are directories, where the dot represents the current directory and dot dot represents the parent directory, or the one above me. And directories are noted with a D. I believe symlinks will start with, let me check real quick. Symlinks begin with an L, but normal files will just have a regular TAC. And then there's these, green, red, and yellow letters. So let's look at main.c, for example. So the first section here are the permissions for the user. The red section here are permissions for the group. And the yellow section is for everybody else in the system. So a user is someone like you or me. In my instance, I am a user called Sadly, and my group is called Sadly, but I can create, another group with its own special permissions, such as students. So the user Sadly might be in the students group, but this example is pretty simple. I'm just in the Sadly group. So the Sadly user has permission to read and write, and anyone in the Sadly group has the permission to read. And anyone who's not Sadly, or anyone even not in the Sadly group, can still read the file because they have the read command. but anyone not in the saddle group or not the saddle user doesn't have permission to write to this main.c file. And it looks like here there's an executable file called a.out, and I can tell it's executable because the user sadly has the extra permission to execute, which is this X. So essentially, just 3 letters: read, write, and execute. It's pretty easy to remember. If you use something like the chmod command, you might need to use these numbers, these octal numbers. So essentially here I have an example. A.out has the permissions 0755 because if you look at the bits set, that's what they are in binary. So read and execute is 101 because the write bit isn't set, so that would be a 5. Does anybody have any questions about file permissions? All right, cool. I guess I'll move on then. And okay, that's the end of the presentation. Pretty short. Didn't want to go super in depth because I kind of just wanted to move on to a lab or something. Does anybody have any questions before we move on to, I guess, try Hack Me or Over the Wire? All right, cool. So which one do you guys want to do? What do you guys think is better? I don't think I've actually done a try hack. I don't think I've actually completed the try hack me room for it though. So I guess we can. I guess we'll move on to try hack me. If you don't have an account, oh wait, actually let me stop recording because the presentation is over. Almost forgot.